Hello everyone. Good morning. Are you able to hear me?
Yes, sir.
Okay. Hope everybody set up your NiFi environment, local NiFi environment. Uh, in our last session, we have discussed how to ingest files with Apache NiFi. Hope everybody set up their, NiFi local environments. Anybody have any questions or queries related to the local setup? Bablu, did you set up your NiFi environment?
Yes, sir.
Are you able to the pipeline we have discussed?
Yeah.
Okay. Sai, how about you?
Yeah, done, Venkat.
Okay, okay. Anusha, are you able to set up your Wi-Fi environment?
Actually, no, Venki, will do
Okay,
today.
okay, fine. Prakati,
Yes, I'm good.
done with your Wi-Fi environment?
Yeah.
Okay, okay, fine. So let's move on to the today's session. Today we will discuss few more things about NiFi. So how we will connect to RDBMS system or a database system, and then how we will ingest data to Google Cloud platform. So this is the concept that we're going to discuss today. So let us understand that pipeline, and then today we will discuss about one use case on NiFi as well, right? So let me quickly share my screen. Okay, hope you're able to see my screen. So yeah, okay. So today we will see how we can actually ingest data into Google Cloud Platform from an RDBMS system using NiFi. So we have seen Python based data ingestion, a Python code or Python application to ingest data to Google Cloud Platform, and then we also seen ingest flat files using NiFi. Okay, so let us understand how actually a project works. Okay, then we will jump on to that NiFi pipeline. We will see a project use case, right? So then we will jump on to the NiFi pipeline. So why we are discussing all these things, right? So why we are focusing on data ingestion, right? So let us quickly see a use case so that you all will get to know how actually a real-time project implementation works, right? Now let us say I have different source systems. Okay, assume I have my business or my client or my customer have multiple different OLAP systems or OLTP systems. Okay, so here if you see, SQL Server is one of the data warehouse for my customer. Okay, and there is a Oracle data warehouse. Okay, and then there is some SAP HANA. Okay, so these three are my customer data warehousing systems. Okay, now on this data warehousing systems, there are a lot of applications or there are a lot of reporting uh, platforms that are running in. Okay. Now, my business owner decided to implement some kind of advanced analytics kind of machine learning. For that, he need this entire data to be placed in a central platform. Okay. So he want to implement a global data lake system. Okay, he want to implement a global data lake system, so that on top of that he can build uh, advanced data analytics like machine learning and data science. So he want to ingest all these data sets that are there in all these three different source systems. Okay, so data ingestion is the first part. Ingest. Okay, in this process there are a lot of strategies that we will follow. Okay, there are a lot of strategies that we will follow, whether to go for Python or whether to go for tool based data ingestion, or whether to use any kind of a third party uh, softwares or tools to push the data, right? So this ingestion process is altogether a project strategy. Okay, do we need to go for a full load, do we need to go for incremental, or do we need to go for a CDC? So these are the different load strategies that we will follow. Okay, so what are all these strategies we will discuss when we were in BigQuery concepts, but right now understand how actually we do ingest, right? So your targets may be two things. In your target space you'll be having two things. One, you may ingest it to GCS. Okay, your flow will go like this, right? So you may ingest it to GCS, and from there you may read data to Dataproc. So we know Dataproc is a big data processing engine or big data processing framework inside Google Cloud Platform. Okay, so we use Dataproc to read these GCS files, whichever we ingested. Okay, and we process using Dataproc, and then we load them. Okay, so the concept goes like this, right? So the flow goes like this: we ingest data to GCS. Okay, and we use Dataproc to process that data, and then finally we load the processed data to BigQuery. Okay, so this is one flow. This is a few projects will follow this particular flow. So you can ask me a question. Hey Venkat, we can load it once, and then or we can ingest data to GCS, and we can manually load Dataproc and then BigQuery. So one day you will do that. But how your entire components, right? Let us say you have one ingest pipeline in NiFi, okay, and then you have one processing job in Dataproc, and you have one load job in BigQuery or stored proc in BigQuery, which will be which can be utilized to load the data, right? So you have multiple different jobs, right? So how you will connect all these jobs, how you will implement dependency. That means one after another, one job after after completion of one job successfully, how we will trigger another job. So this is called orchestration. We already discussed about these concepts, but I'm just refreshing for you. So this is called orchestration. Okay, orchestration. So this orchestration you can do in workflow, Google workflows, or you can also do it in NiFi itself. Be very very clear. NiFi is also powerful to do orchestration. Okay, meaning you have a ingestion job. Okay, and then immediately you can trigger a data proc job in NiFi itself, and then immediately you can call a BigQuery stored proc, or else you can load data to BigQuery. Okay, so this orchestration is also possible in NiFi. Be very, very clear. Okay, people who are interested in exploring NiFi, you can also do this orchestration in NiFi when we are proceeding further. Definitely, we will discuss cloud workflows, no doubt in that. But few projects also utilize NiFi for better orchestration or better flexibility. NiFi has very good flexibility, very good user interface to do orchestration, right? So this is one way. The second way is Venkat, we won't be able to learn all these stuff like the GCS, data proc, and all. We can go with only BigQuery. Okay, so you can actually use NiFi along with BigQuery. Okay, so how you will do that? So here, if you see, you can directly ingest data to BigQuery, Google Cloud BigQuery. Okay, so let us say we will ingest data to BigQuery stage tables first. Okay, BigQuery stage tables, we call them as stage tables or intermediate tables. Okay, so we are discussing two project architectures here, guys. Be very, very clear. Going with ingest to GCS, and then processing in data proc, and then loading to BigQuery. Then after loading to BigQuery, then your modeling or machine learning jobs will run. Okay, as and when we load data to BigQuery, then we will trigger the machine learning model or the data science models or traditional reporting jobs, whatever it is. So the downstream will be, it may be data science team, okay, or machine learning or reporting. Okay, so we build pipeline, a automated data pipeline in NiFi or in workflows by connecting all these jobs into one data flow or pipeline, and trigger that pipeline every day or trigger that pipeline according to the schedule given by the business users. Okay, so that once we schedule that data pipeline from end to end, meaning from source to target, okay, once we schedule that data pipeline, it will run daily, okay, or it will run weekly, or it will run monthly, depending on the business users uh, schedule. That pipeline will automatically trigger, go and fetch the data from these three sources, ingest into GCS for that particular run, and then trigger the processing jobs for that particular run, and then load the data for that particular run into the tables, refresh the target tables with latest data, and then trigger the data model jobs. This pipeline, this entire pipeline will be owned by data engineer. Okay, be very, very clear. On a day-to-day fashion, what we do, we build this kind of data pipelines. Be very, very clear. Okay, it is not a one-day job. On a high level, just to make you very, very comfortable with data engineering, I'm explaining these concepts upfront. Okay, so in day-to-day fashion, we develop this kind of pipelines. We may take 1 month for ingestion framework. We may take 1 more month for processing framework. We may take 1 more month for building stored procedures in BigQuery. See, it's a kind of altogether 6 to 7 months project implementation, guys. It's not that much easy that you think. Okay, we may be reading data from 100 to 1000 tables from your source systems. Okay, for each and every table there will be a separate logic and functionality that will be put in, right? So you need to understand that entire logic and functionality. You need to implement that processing logic and loading logic, whether it's a full load pattern or incremental pattern. According to that, you need to build your pipeline. So this is not as simple as we think, but on a high level, definitely, if you can understand this particular flow, it will be very easy for you to implement. If you don't understand this particular flow, it will become very complex. Oh my God, why we are learning all these technologies? Oh, sometimes Venkat will say SQL, sometimes Venkat will say Python, sometimes Venkat will say stored procedures. So why? What is the purpose of all these things? Okay, you need to understand the purpose first. That purpose will drive you. That purpose will drive your learning. Be very, very clear. Okay, so the purpose is building data pipelines or developing data pipelines. Okay, so the orchestration part, data proc and BigQuery, these are the three things that we are left with. We are done with the ingestion. Be very, very clear. Okay, we have done Python based data ingestion to GCS. RDBMS based data ingestion you have already done with Python. Now we have done flat file based ingestion using NiFi. Now today we will complete RDBMS based data ingestion to GCS. This is for this particular flow. There is other flow as well. Few people who are who want to go with only BigQuery, that is also possible. Okay, so you can take the data to from all these sources and ingest data to BigQuery itself into the stage tables, and then again load the data into BigQuery target tables after processing in BigQuery itself. BQ, final layer or integration layer, we call it as integration, or few projects we call it as target, final. So this is the target layer. Okay, and this is the stage layer. In BigQuery itself, we'll maintain two layers. One is the stage layer, another one is the target layer. So we'll do ingest first into the stage layers. Okay, okay. So we do ingest data first into the stage tables, and then we will trigger all the stored processes that are required for loading target layer. So people can also follow this way. Okay, so but your technology exploration or your services exploration will be very limited in this approach. When we will go with this flow one, and when we will go with this flow two, we'll discuss now. We'll get one clarity. Okay, let us assume your source data is completely RDBMS based data and it is properly structured. Then you can pretty well go with this BigQuery based flow. Okay, but if your source data is text files or log files, or it does not have any proper schema, or even if it is a very very what we can say RDBMS data, but it's very huge data, and you want to process it in very less time, in that case you will go with the upper flow. You have very limited data and very less volume, and you have one-to-one mapping kind of a stuff, very less logics involved, uh, less processing logics involved. Then you can pretty well go with this approach, the downside approach. Okay, so use case one and use case two, be very very clear. Two use cases. Guys, any questions in these use cases? These use cases are very important because the coming sessions are completely depends on these use cases. Okay. Now ingest data directly to BigQuery, we will see today. Okay, using NiFi. You can also ingest data to BigQuery using Python client. That we will discuss when we were at BigQuery. We'll do one thing. We'll do ingest to BigQuery directly in BigQuery concepts. Okay, I don't want to confuse you guys. So first we will go with this flow. Okay, the upper flow, which actually most of the projects will follow. Okay, The second approach is for the people who are not pretty much interested in coding, and I want only the SQL based implementation and tool based implementations. Then in that case, you can pretty well prepare your resume in such a way that you put NiFi and then BigQuery, and then for orchestration also NiFi, and for processing also NiFi, BigQuery, and then you can put only GCS and BigQuery along with NiFi. That's how it creates your one of the lightweight resume with less services involved and less coding involved. Okay, so if there are projects which only utilizes BigQuery and ingestion process, then that project's requirements will call you. Okay, that's how it goes. If you go with the upper flow, the permutation of your resume picking will be increased. Okay, because a lot of services involved here, so you will be looking at uh, even cloud functions also here, and then we also touch PubSub, right? PubSub. Okay, so I'll be concentrating or more focused on the use case one. Be very clear. Use case two is a less concentration for me, because the calls, once you the end of the day, our goal is to get calls from multiple different companies. Okay, so the companies will definitely pick a resume which have a lot of services involved, or a lot of technology exploration is there, right? So if you put only NiFi and BigQuery, the chances of your resume getting picked from companies will be very less. Okay. So any questions in understanding these project use cases, guys? And this is the roadmap for us for coming 1 month. I can say we can complete data proc and BigQuery within 2 weeks, in coming 2 weeks. Okay, and then we will look at the orchestration part of it in NiFi as well as in workflows. Okay, so any questions or queries you can call out. Are we clear in this?
Yeah, clear.
Yeah, Venkat.
Okay, so now today let us understand. I don't know how many of you are completely dedicatedly practicing. Okay, so NiFi is something that I strongly recommend for you to understand and put in your resume. Okay, so because we can do a lot of things with NiFi. Okay, we can do a lot of things with NiFi. It is not only for ingestion. You can do a lot of pre-processing also in NiFi. You can convert file formats in NiFi. You can build orchestration in NiFi. You can actually schedule your data pipelines in NiFi, right? So lot many things you can do, guys. Okay, so I strongly recommend your resume should be having, along with Python and SQL, the next technology that you need to put is NiFi. Okay, and then we will put GCS, data proc, BigQuery, cloud functions, and then workflows. This is your skill content. Okay, once we have seen a project, end-to-end project, by combining all these services in the last week of our sessions, then I'll show you a demo resume. I'll show my resume itself. Okay, how you need to prepare your resume. Okay, once you prepare your resume, once we discuss the project, you need to put that project in your resume, and then you need to upload your resume into all the platforms that we have, LinkedIn or Naukri, whatever the platforms that we have, right? So this is the roadmap for us. Let's stick to this roadmap, and then let's try to complete. So this cloud function and PubSub are very lightweight topics for us. We'll complete them within 2 to 3 days. Okay, our major focus is data proc and BigQuery. These two are the very important services in entire Google Cloud platform. Okay, for a typical data engineer. Okay, fine. So let us quickly resume our NiFi sessions. So today the major focus is building a data pipeline or developing a data pipeline which will ingest data from SQL Server to GCS. Okay, from SQL Server to GCS. So here, let me quickly give you a use case as well. After this session, I want you to build a data pipeline in NiFi. Okay, it's a use case in NiFi itself. Okay, so here, if you see, I have table one, table two, and then table three. Okay, let's see, I have five different tables. Okay, I have five different tables. This is the requirement that you need to do, guys. Okay, so by tomorrow, you need to complete this requirement. So you need to build NiFi pipelines for each table. Okay, for each table. So for every table, one pipeline, guys. Remember, for every table, one pipeline. Okay. Now you need to ingest data into the specific path. Okay. Here the path is bucket slash data, or else we can say sales underscore data, whatever the main uh, functionality of your data. You can pick it, whether it's maybe employee data or sales data or retail data or e-commerce data or whatever it is, right? So then you can say raw. Okay, raw layer. Okay, then table one slash mmdt. Okay, so this is the path that you need to build. Similarly, the path won't change for table 2, so you just put the table name. That's it. Using NiFi, you need to build five pipelines for five tables, five different tables ingestion. Using NiFi, you need to build five pipelines for five different tables and take all five different tables from one business functionality called sales data or employee data or college education data or something like that. Okay, so this is your use case for tomorrow. Okay, by tomorrow you have to complete this task. Once we have seen RDBMS based ingestion today, by tomorrow you have to complete this task. Okay, so this is how inside this you need to put the CSV files. Okay, fine. So now let us quickly log into our NiFi and then see how we can actually implement the data ingestion. Okay, so the similar thing from our last session. So we'll just go through our username and password. Okay, fine. So in our last session, we have clearly discussed how we can ingest the flat files by using the get file processor. So get file will read the data from a filer path or a location, Okay, in real time, it may be a Windows location or Linux location. And from here, we will read that files, flat files, and then we will use put GCS object is the processor will use, and then we will load the data into the respective paths. Okay, fine. So this is one implementation we have discussed in our last session. Okay, the flat file based ingestion. Okay, so here, if you see, I have created one process group. Okay, so you here in the taskbar you have process group, right? So you just pull that process group in. I mean, for every table, if you want to build a pipeline, I suggest to create the process groups for each table. Okay, and in that process group, put that pipeline. Okay, so here if you see, I have a generate flow file processor. Okay, generate flow file, meaning the functionality of this processor is it will generate a empty flow file. Okay, it will generate a empty flow file. Okay, so why we need to use this processor? So the reason is in NiFi, few processors needs a trigger, right? Upstream trigger. We call it as upstream trigger. It may be execute SQL, or it may be replace text. Some processors are there, so they need upstream triggers. Even your put GCS object also. So they need to have one flow file to trigger these processes. Okay. So similarly, this generate flow file we use in real time more often to generate empty flow file to trigger our actual processing. Okay. So this generate flow file, when we start, it will generate a empty flow file. That's it. See here, a 0 byte empty flow file. This is queue, we'll call it as. Okay, this is queue. Okay, inside queue we will have one flow file. Okay, which is 0 byte. Okay, now let us understand the execute SQL. So in the execute SQL, we need to prepare our connection string first of all. Oh, correct. So for any database to connect, or for any RDBMS system to connect, in Python, what we have done, we prepared a connection string, right? So in NiFi, we call it as a controller service. Be very, very clear. In NiFi, we call it as a controller service. So we use controller service to connect to RDBMS systems. Okay. For that matter, even for the GCP also, we have developed a controller service in our last session. See here, GCP credentials controller service. Guys, are you with me? Are we clear? Any questions?
Yeah.
So, if you have any questions, you can stop me, guys. Don't be in confusion state. Okay. So in our last session, we have discussed how to create a GCP credentials controller service, right? So we have created a GCP credentials controller service, correct? So similarly, in NiFi, you can create multiple controller services. Okay, multiple controller services. These controller services can be utilized to connect with the RDBMS system. Okay, here if you see, when you right click on your canvas, and when you click on configure, if you right click on your canvas, we call it as a canvas, right? Pipeline canvas. So, and then click on configure. In the configure, you'll see general and controller services. Controller services you need to click. Okay, and then click on plus symbol. Okay, click on plus symbol. So here you see, if it is a database, you see DBCP connection pool, right? So this one, database pooling, database connection. So if you want to connect to any of the database, it is not only SQL Server. If you want to connect to Oracle, or if you want to connect to any kind of a Snowflake database, or any database, you can utilize this DBCP connection pool. Okay, so you can click on add, So this is something that got added, and then you can click on configure. You can change the name to SQL Server Connection Service, right? And then you need to configure it, right? You need to configure it. So for the configuration, you need to go to Properties tab. In the Properties tab, you can see all the related properties are there, correct? You have connection URL, you have driver class name, and then driver file location. All these things you need to configure. Okay, so how we will configure? Let us quickly see our one configured connection service. Okay, I have already configured it. Let us see this. Here, if you see, this is how we will create the connection URL. Okay, see here, I'm using JDBC connection utility colon, the database name is SQL Server colon slash slash your server name. Okay, your server name, that means your laptop name, or in real time it will be the server IP or server name. We follow server names, right? BO HDP prod 01 prod 02, something like that. So some server name where actually your database is running, and database name, which database you want to connect. Okay, retail. And then encrypt, if you want to encrypt true or false, you can put. Okay, and then username, password. Okay, this is how you will form the URL. Okay, now in Python, when we were discussing RDBMS to Python connection, we have discussed a driver, about driver, which will be acted as a medium or a bridge to connect to the database systems, right? And we also mentioned the driver version, driver class name in the utility connection utility that we are preparing in Python, right? So similarly, here also we are providing the driver class name, and then we are giving the driver jar file. In Python, when you say pip install pyodbc, you will get these jars by default into Python, so that it won't ask for you to dump this jar. But in NiFi, you need to tell NiFi, hey, there is a connection jar, or there is a connection utility jar that is placed in my directory. Go and read that connection utility jar, and then use this driver class from that utility jar and connect to this database using this URL. This is what NiFi is instructed with. After configuring these three parameters, this is what NiFi will get instructed. Okay, so any questions here, guys? Any questions? Are we clear with these three parameters? These are the three major parameters that you need to configure when you are building the controller service. Any queries?
Yeah, Venkat, I have one question.
Yes.
Yeah, this class name we have to specify from the
Yes, we have to specify, because in this jar file, so Microsoft, when they build this SQL server, they will build these connection utilities in the form of jars. Okay,
okay.
so in this jar, the main class will be the this one, com Microsoft SQL Server JDBC SQL Server driver is
It's
the
not like that we get it from the Google, right? It's from the jar we have to specify.
uh,
No, or simply the class name I'm asking, like how do you specify this class name? Yeah, from where?
this class name will be given by the Microsoft
Okay,
itself.
okay, okay. Uh-huh.
You can go here, you say MS SQL server JDBC jar file. Okay, so
Okay.
when you go here, if you see, it will route to you a Microsoft website. Okay, when you go here, you can actually see the jar files available, right? See here,
Okay.
they have given the driver with map and central, and you can see the driver path here,
Okay.
com Microsoft SQL Server, right? Similarly, in the jar, right? So you can download your jar here. Okay.
Okay. The version also depends on the server, the version that we are using.
Yes. You can actually no the connection utility. You can download the latest jar also. It is
Okay.
okay
Okay. Okay.
because it will support I mean backward compatibility. So whatever the version that you have in the database, you can download any kind of a jar file.
Okay.
It's
Okay. Yeah.
dependent. Yeah.
Okay. Yeah. Clear. Thank you.
Yeah, here, if you see JDBC driver for SQL Server, you can go to the documentation to get the exact driver class name for it, right? See here, you can go. I mean, you can find it in the Google itself. No worries on it. You just need to download the jar file, put it in your local directory, and pass the directory here. Pass the directory here. Okay, and then specify the driver class here, and then prepare this URL. Any other questions, guys? Any other questions here?
No. Okay.
Venki, can you please open that GCP credential control service also?
Okay. Yes.
Settings.
Yeah, it is different, right? So we Google Cloud, for Google Cloud we have a ADC file, correct? JSON file, application default credentials. So we need to just copy paste that JSON here. That's it, in service account JSON tab, or else you can pass the JSON file path also here. That's it. There is nothing needed for GCP controller service. You got me?
Yeah, okay, Venki.
Yeah. So for Google Cloud to build the controller service, we need the ADC file. Okay. And for RDBMS systems or database management systems, you need to build the connection controller service using the DBCP connection service. Okay. So let me just disable it. Okay. And I'll name it properly. So DBCP connection pool instead of SQL server connection service. Okay, so I'm just applying it. Okay, so now I'm just enabling it again. Okay, you need to enable it. Okay, done. So here, if you see, this is how you will do the controller service configuration. Once you created the controller service, it is very simple to use that service. Okay. Now here, if you see, I have created a process group. Okay. The process group name is database load to GCS. Okay. Database load to GCS. Once I double click on the process group, okay, I have a generate flow file. Okay, so let's quickly build the pipeline because I don't want to show the existing one. Let's quickly build the pipeline. So I'm just creating a process group here. If you see, table load, GCS. Okay, so this is my process group. Okay, this is my process group, and then I'm just double clicking on it. I'm adding the flow now. Okay, processor, I need generate flow file processor to trigger my pipeline. Okay, you can add that processor. Okay, and then you can drag and drop your processors here. So required processor. I have a processor called execute SQL. Okay, I have a processor called execute SQL. So this processor functionality is to go and execute a select query on a database system and extract the data and then put it into a flow file. Okay, put it into a flow file. See here, I got my execute SQL processor. And then once I have data queried from the database system, and then the next step, what I need to do, I need to put it into GCS. So for that, I'm using put GCS processor. Okay, for that I'm using put GCS processor. So three processors. Okay, so now let's try to connect these three processors, right? So here generate flow file, I connected with execute SQL. So the relationship, we need to click success. Okay, after a successful generation of flow file, so we need to trigger the execute SQL processor. Okay, now this execute SQL processor, if you see in the settings, or properties. So here you can select the database connection pooling service. Okay, here you can select the services from the services that you have. SQL Server Connection Service, we already created that service, so it will show you in the drop down. Okay, so then you will click on OK. Okay, if you want to reconfigure it, you can click on this button, so it will go there and open the control service. Okay, so done. So now let's go to table load again, and then in the execute SQL processor, we are configuring pre-query, select query, and then post query. We have three parameters here. Okay, so the first parameter, pre-query. Okay, so the functionality here is, if you want to execute queries in a sequence order, let us say first I want to execute insert and then update and then delete or select, or else insert, update, select, or else delete, update, select. If you want to execute such kind of sequence based queries, right? Sometimes you may need to delete from one table and then pick from another table, or sometimes you may need to delete the previous data and then pick the latest data. So this is how you may need to build pipelines. Sometimes you will get such kind of use cases. So for that purpose, they have given these three pre-select post queries. Okay, so but right now our use case is only select, so we'll go with select query. Okay, so I have tables in my database. Okay, and I have a table called customers. Okay, so let's quickly query our customers table. Okay, so my database is retail, so I'm just querying the customers table. So this is my customers table. Okay, so now what I need to do, I need to put that select query, select star from, select star from customers. Done. Okay, fine. So we have configured the control service, we have given the query here. Okay, these are all different options that you can explore and see. Okay, not mandatorily need to configure. Mandate things are these two. Okay, so you can apply. Okay, so but still it is showing exclamation mark. Remember, when a processor is showing exclamation, meaning it is not configured properly. Be very clear, it is not configured properly, meaning it may need to connect to the next state by using a relationship manager. Okay, so here if you see, every processor have two states. One is success or a failure. Okay, you need to route the relations properly in NiFi, right? So after successful execution of this execute SQL processor, it needs to go and trigger another processor, so that the success relation I have connected with another processor, and the failure relation I want to see all the failures, or I want to send an email. So you can connect to some other processor here. Okay, so now here, that's when you see, once you connected these relations, your processor is turned into this pause symbol, right? From the exclamation to pause symbol. So similarly for your put GCS object processor, right? So here I have a lot of configurations, right? So let me simply copy paste this processor from my previous. I'll just control C, and then I'll go to this table load. I'll just remove this for a while. Delete is the keyword. Delete is the key that I'm using. Okay. Now I'll just try to connect success here. Okay. Now for put GCS processor, if you see put GCS object, we have project ID specified, and we selected our GCP credential control service, and the number of retries is 6, and then bucket we have provided, and then key, the file path, we provided, right? And then apply. Okay. So now again we need to once the data got loaded to GCS, here you can trigger any other processor, like data proc, something is there, HTTP request, we invoke HTTP, right? So post HTTP or invoke HTTP. By using these things, we can do a REST API call to our data proc jobs to trigger. For now, we will just want to end this process here. So we'll route the success to a funnel. Okay, and then you also route the failure to a funnel. Okay, so this is the best practice actually for every process. You can route the failure to a funnel. Funnel is something where you want to queue, stop and queue, right? Then you can use a funnel there. And funnel also can be utilized to centralize the process, meaning, let us see, I can only use one funnel for all the failures. Okay, see here. Okay, and then I can route this funnel to one of the email processor or something. Put email, right? So something like this, right? This is how you will build the pipeline, guys. Okay. Okay, so now we have everything ready. Let's quickly start our pipeline. Okay, run once. So remember, when you are using generate flow file, make sure you go here settings, or else not in the scheduling. Okay, keep only the primary node. Okay, this is the option that you need to do. Otherwise, and then run schedule also. Here, if you see, keep it 5 minutes at least. Otherwise, it will keep on generate the files from all the nodes. Okay, so that's the only option that you need to change here: scheduling, primary node, and then run schedule. Keep some run schedule. Okay. Now I'm clicking on run once. Okay, I got my flow file. So it will now trigger my select query. Okay, successfully completed. You can go and see the flow file by clicking list queue. Okay, So where I'm doing, guys, once again, so I'm clicking on the queue and right click, list queue, okay, and go and click on this I symbol, okay, and here if you see details and attributes, okay, you can see all the attributes, flow file name, view ID, right? How much time it has taken to fetch the records, file size, everything you can see. This is all metadata, guys. Okay, this is all metadata about the file, flow file. Okay, you can click on view and see this is how you actually your NiFi will generate the flow file, right? So if you see the data, it will be in a different format, isn't it? So the default flow file format that NiFi will follow is Avro. Okay, so we have different file formats. Okay, in big data engineering or for that matter in data engineering or in cloud data engineering, we have different file formats. Be very clear. We have different file formats. CSV, we know it's a comma separated value. Okay, we have text files. Okay, we have log files .txt, .log. Okay, and then these are traditional file formats. We know these file formats from so long. JSON, this is also one of the file format, right? But for big data processing or for big data engineering, we have few new formats or file formats that got introduced, okay, which are very performant and which are very optimized in terms of storage, in terms of processing. Everywhere these file formats are very important. Okay, we'll discuss about them, but for now I'm just a high level glimpse I'm just providing. Okay, Avro is one of the file format. Okay, ORC is one of the file format. Okay, these are big data file formats. Okay, and then Parquet is one of the file format. And very recent evolution in data engineering file formats is Delta. Okay, which is advanced Parquet. We call it as Delta is one more file format. Each and every file format has its own significance, has its own functionality. Okay, we will discuss about all these file formats in our tomorrow session, but for now the NiFi internally it selects Avro as a default flow file format. Okay, all the flow files that are traversing or traveling between the processors will follow Avro file format. Okay, so we'll discuss about all these file formats in our tomorrow session. But for now, see here, this is Avro file. So the flow file content you are seeing, and this is Avro format. Okay. And if you want to see it in a properly text format, you can click on formatted so that you will see the JSON records, list of JSON records. Right. This is the data from your select query. Okay. Fine. Guys, any questions here?
Yeah, Venkat, I have one question.
Yeah.
Like, how much data each flow file can handle?
It depends on your NiFi server configurations, actually. Let us take an example. My NiFi server is a beast, and I have very beast NiFi cluster. Then in that case, they can increase or you can put your queue size very much. Right? See here, size threshold. You can, if you, for example, if your size threshold is 1 GB, then end of the day, you can only place 1 GB in the queue. Okay, how that 1 GB is deciding? That 1 GB is coming from your resources, right? So your NiFi cluster will be having few resources. It is also a cluster environment. Primary node, master node, worker nodes will be there, right? So based on your NiFi cluster node configurations, your threshold will be decided. For example, few organizations will follow like 750 MB, few organizations will follow 10 GB, right? When we put that configuration in the queue size or threshold size, what will happen? It will be pulled from the NiFi nodes, right? So when NiFi nodes have that availability, it can pull. If NiFi nodes don't have that availability, or it's a limited cluster, then they will limit the queue size to 1 GB or 750 MB or 500 MB. It depends on your NiFi cluster, on the number of pipelines that are running in your cluster. End of the day, it should not stop other pipelines, right? So when you say queue threshold, you don't have actually a limit for the flow file to pass on, but the limit will be pushed from your NiFi administrator, wherein it depends on your cluster configurations as well as the number of pipelines that are running. If you keep on increase your thresholds, and if you keep on put whatever the size you need, then what will happen? It will hamper your NiFi cluster, and it will also make down other pipelines that are running successfully, right? This is the history behind this. There is no hard limit, but it depends on the constraints that we have. These two constraints. One is the cluster configuration. Another one is the number of pipelines that we are running.
Okay. Okay. Thank you.
Any other questions, guys? Any other questions? Okay. So now let's move on and trigger our put GCS object processor. Okay, here let's change our path properties, and then here I'm just saying test underscore NiFi. Okay, apply. Okay, and then let us quickly trigger it. Run once. Okay, passed, and it went to success state. Okay, now let's go back to our bucket and check how our data is coming. Okay, test NiFi. Right, this is mp.csv. See here, this is something that you need to understand, guys. Again, so what you have done, you have directly ingested your flow file to GCS. So your flow file format is Avro, but you have given CSV extension, but the content that is there in your flow file is Avro. So NiFi directly pushed your content to that file. So this is where the file formatting is very, very important, right? So in real time, what we do is we convert this flow file records to Parquet or Avro or other formats or CSV for that matter. We convert and then we will write it into the respective destinations. Okay, so this thing we will see tomorrow session, but tomorrow we need to understand how actually the file formats will work, what are different file formats that we have. And tomorrow we will see very important concept in NiFi called variables. Okay, like Python, NiFi also have a concept called variables. So when you are working in any canvas, if you just right click and then go to variables, right? You can declare your variables here. Okay, you hard coded the data in these processors, right? So instead of hard coding, what we do in real time, we use the variables to put those values into variables and then use the variables in the pipeline. Okay, so that is other a concept that we're going to see tomorrow. We will see the file formats and then variables in NiFi. Okay, so hope you are clear with RDBMS based data ingestion, okay, to GCS. Anybody have any questions? Again, I'm asking, see, because this is very important, guys. Don't be with confusion state. Please ask, even if it is small question, it's okay. Even if it is wrong question, also it's okay. Don't be with confusion state. Okay. Any questions? I'm asking final time. I don't repeat all these concepts, guys. That's the reason I'm asking.
Venkat, I just had a question.
Yes.
So, is there any specific reason for executing the processor ID once, like you are executing one at a time, right? So,
Yes. So you can actually keep you can trigger the pipeline and leave it. It's okay. But let me show you why I'm doing it. Here, if you see your generate flow file or your schedule, you need to look at. I have given 5 minutes, right? So if I start it, and then I'm also starting this, okay, and I'm starting this as well. There is nothing that's going to happen, but if your schedule is 0 seconds, assume by default it is 0 seconds, okay, so or 1 minute. So every 1 minute it will start triggering the flow files, and it will keep on running. But in real time, this is how we will leave the pipelines. We will put proper schedule, and then we will run, and then run all the processes, and then we will leave it. Okay. See here that after 5 minutes only it will trigger again. After 5 minutes, it will trigger again. This is the reason why I will just click on run once. We will test by using run once, and then we will put proper schedule, and then we will start every process, and then we will leave it in the production. That's how we do in real time. But
yeah,
in development, we always play with this run once so that we can test each and every processor output, and then at the end we will trigger the entire pipeline.
yeah, clear.
Any other questions? Come on, guys, ask. It may be see, we have discussed one task for tomorrow. Please be on top of it. So this is your task. You need to build NiFi pipelines. Okay, one process group for one table. Okay, one process group for one table, and inside that process group, you need to build your pipeline for that table. Okay, and I like that. I want to see 5 process groups, so that we'll discuss input and output ports also tomorrow, and then funnel functionality you will see tomorrow, how actually in real time we'll use funnel, right? So day by day we are maturing, guys. I mean, we are increasing our NiFi or pipelining skills day by day, and we are seeing new concepts day by day. So I request everybody to practice and explore things, okay, and implement your own pipelines, so that it will really help in understanding all these concepts. Okay, so that's all I have for today, guys. Tomorrow we will discuss about the file formats, and then a few more things in NiFi, and then we will close the NiFi for tomorrow. Okay, and then we'll quickly jump into the BigQuery. Okay, so that's all I have for today. Thank you so much for joining once again tomorrow.
Thank you, Venkat.